We're going to solve this absolute value inequality, and we'll do it the same way we solve the other ones. We'll start by translating this from symbols to English. So let's start by translating the left side. Now we know as soon as we see absolute value, we're thinking distance, and this translates like this. Here's our template, right, with our blank field. The distance between the number, and that number is that one right there, and 0 on the number line. All right, so that's the left side. So let's go. The distance between the number, now here's our number. Let's put it in here. Negative 3x plus 4. Now keep going. And 0 on the number line, and then what does it say? Is less than or equal to 7. And it says is less than or equal to 7. So let's draw a number line. X, here is 0. Now, what's our bound? We're bounded here by 7. So we're going to pick this number up, start here at 0, and we're going to move it out and locate it somewhere on the number line. But where can we move? We can move what? Less than or equal to 7 units away from 0. So if we start here at 0 and come out here to the right, that would put us at positive 7. Now it's a less than or equal to, so I get a closed circle. And we could drop that negative 3x plus 4 anywhere here. Or we could take this negative 3x plus 4 up here, walk it down here, and move it anywhere to the left, but we're still bounded by 7 units. But if we go 7 units to the left, we're at negative 7, and then we could drop it anywhere in that interval. So that negative 3x plus 4 could be anywhere from here to here, and if it's anywhere in here, sure enough, we're less than or equal to 7 units from 0. Now, just bring everything straight down. If you bring it straight down, we will see our inequality. So if I bring that all straight down, I'm looking at this. Negative 7, less than or equal to the negative 3x plus 4, less than or equal to positive 7. Right, when you do it this way, these arrows always point to the left. All right, so let's solve this. So what we're going to do, of course, here is we're going to subtract 4, divide by negative 3. Now, I will do that up here. So let me just get a little bit more room. I'm going to take that inequality, and so I'm going to solve this inequality, but let's get a little bit more room, you know, it's by magic. I'm going to take it up here. Now, let's subtract 4. So if we subtract 4, we're at negative 7 minus 4 is negative 11, less than or equal to negative 3x, less than or equal to, and 7 minus 4 is a 3. And now, let's divide by that negative 3. Alert. Oh, now look at this. We're dividing by a negative, so we know we're going to change the direction of those inequality symbols. So now we are looking at this. If I divide by negative 3, well, I'll show it here. Negative 11 over negative 3 greater than or equal to x greater than or equal to 3 divided by negative 3. And this gives us 11 over 3 greater than or equal to x greater than or equal to 1. Now, we've got an answer here, but this is just awkward. You know, it says this number is bigger than that number, and in turn that number is bigger than this number. This is kind of the opposite way we read, right? We usually read numbers smaller to larger. It's like this. If somebody said, how old are you? You don't say, well, I'm between 30 and 20. You would turn it around. I'm between 20 and 30. So that's what I'm going to do here. I'm just going to, just imagine picking this thing up and turning it completely around. It would look like this. 1 less than or equal to x less than or equal to 11 thirds.